Next we move on to another hyperbola. This is a particularly interesting hyperbola because what the visualization of this particular conic is not as easy as the earlier ones which we discussed. So let's first of all see what's its definition. The definition of the hyperbola is the set of all points in a plane, the difference of whose distance from two fixed points in a plane is constant. Likewise, in the ellipse, we have just uh, the 2 points, and these 2 points are called the foci. After seeing this particular, what I note is in an ellipse and hyperbola share very many similarities. Only the sum in all the formulas and all the equations of the ellipse are replaced by difference in hyperbola equations. So I'll when I derive the general expressions, I'll point out the differences which we have and analogy between the ellipse and the hyperbola in all the equations. So basically, this particular blue line is called the hyperbola. Here we have the 0, 0 as the center. This particular point is the vertex, and this particular point is the focus. Here, as earlier in the ellipse case, the line passing through the focus through both the focus is called the transverse axis. This particular is called the conjugate axis, and these things you may not be bothered. You should not be bothered now. So here also we have a relation, likewise as we had in our ellipse. So we'll use the definition here. Before going to derive this relation, let's first of all see what is the distance difference which we have as we had in our ellipse case. So taking this point as this point lies on the ellipse, first of all let's see what is the coordinates of the focus. So the coordinates of the focus are here also minus c comma 0, c comma 0, and the center is 0 comma 0. This particular point is a comma 0, the vertex 1, and the second vertex is at minus a comma 0. Now if you just look and so let's calculate the difference of the distance. So what do we mean by the distance? We'll see here. The difference is let's say if we take the difference of this point, so the difference is taken as the distance from the foci which is farther to that of the distance of the foci which is nearer. So the first distance will be equal to c plus a. Let's write down the first difference would be c plus a minus the distance of the second vertex from this particular point will be c minus a. So we'll have c minus a. So the difference is equal to 2a, which was, as you can see as the analogy from the ellipse, was where the sum of the distance from the two foci was equal to 2a. So we have here the distance equals to 2a. So to derive the relation, what we note here is that likewise we'll again as we had an ellipse, we have a relation a square plus b square equals to c square. Though b doesn't have an actual real meaning here, but we still define these points, this particular point as 0 comma b, and write and assume this relation as it will occur in our particular derivation. So a square plus b square is equal to c square. Now these are the general equations of the hyperbolas. In this particular case, we'll have our principal axis parallel to x-axis, and the center will be at 0 comma 0. If we have a center at h comma k, simply this x will be replaced by x minus h, and this y will be replaced by y minus k. So the equation for this particular curve is x square upon a square minus y square upon b square equals to 1. You might be wondering what b is. So using our earlier relation, the b is equals to root a square minus c square, root c square minus a square. Sorry. And in the second case, we have our principal axis. This is the principal axis parallel to y-axis and center at 0 comma 0. So we obtain relation y square upon a square minus x square upon b square equals to 1. In this particular diagram, we'll try to find out the relation of or the general equation of the hyperbola. So these are particular these are particular focus S and S dash, H and H dash are the vertices, and this particular line is the directrix. We generally don't need the directrix in our use of hyperbola and ellipse. So to derive the relation, let's write out the this by using the distance formula. So the distance is equal to x plus ae square plus y square, the under root, plus under root minus x minus ae square plus y square is equal to 2a. Now taking this particular term on the RHS and squaring, we obtain x square plus a square e square plus y square plus 2aex is equal to x square plus y square plus a square e square minus 2aex plus 4a square plus 4a under root x minus ae square plus y square. It's just simple mathematics. Try to figure out on your own. And after doing this, just cancel out the common terms and you'll be left with ex equals to a plus under root x minus ae square plus y square. Take this a on the LHS and square again. So obtain a square e square x square minus 2aex equals to x square plus y square plus a square e square minus 2aex. Again, just cancel out the terms which you see common here. This term won't cancel out. I'm mistaken here. Just let me erase this. And now taking the terms of x square, this particular term on the RHS and this term on the LHS. Let's take all the terms on the RHS first. So we have 0 equals to x square minus a square into 1 minus e square again minus y square. So now putting the value of e to be equal to 0 equals to x square minus a square 1 minus c square by a square, and doing the simpler algebra you will obtain this particular equation, this general equation. Do remember this equation and remember the situation in which it occurs, that is when the principal axis lie on the x-axis and the center is at 0, 0. This is the last and of utmost important concept, that is the latest rectum. This term might seem very alien to you, so let me introduce this for this particular term. So it's defined as the line segment perpendicular to the axis and passing through one of the focus whose endpoints lie on the conic. This definition is not very clear from its particular assent, but let's try to work out in the case of different conics. So let's first of all see a case of parabola. So if this is a general parabola whose center is at 0, 0 and focus it is at a, 0, then this particular line which is let's follow the definition, perpendicular to the axis, it's perpendicular to the axis, that is the x-axis and the axis of the parabola, and passes through the focus, that is this particular point a, 0, and endpoints of this particular endpoints lie on the conic. So this is a latest rectum of the parabola, and you can derive its length and the point at which it strikes the particular conic and say parabola by simply putting say this particular line will be equal to x is equal to a. So just putting x equal to a in our general parabolic equation, that is y square equals to 4ax, we obtain y square is equal to 4a square, which gives us y is equal to plus minus 2a. So the equation through the equation we have derived the points at which it strikes, that is a comma plus minus 2a, and the length of this particular latest rectum will be 2a plus 2a, so will be 4a. For the next cases of ellipse and hyperbola, we'll work out a simple case of ellipse, and I would like you to work out the other case of hyperbola. They're very easy and pretty simple to work out. So for the ellipse case, let's try to work out. So let's take an ellipse which whose principal axis lies the x-axis and whose vertex are at c comma 0 and minus c comma 0. So as you can see, this particular conic has two focus. So we'll have two latest rectum here. One will be passing through c comma 0 and another through minus c comma 0. So now following the same particular technique here, to locate the point at which it strikes the curve, we'll put the x coordinate of the latest rectum equals to c. So let's first of all write down the general equation of the ellipse of this particular type. That's equal to x square by a square plus y square by b square equals to 1, and put x equals to c. So we'll have c square upon a square plus y square upon b square is equal to 1. Now using the definition of eccentricity is equals to c by a, we'll have y equals to plus minus b into, so we'll have y equals to plus minus b under root 1 minus e square here. And as you have noticed that we have a relation that says that 1 minus c square by a square is equal to b square by a square in the case of ellipse. So we have y equals to plus minus b square by a. So now we have the y coordinates, so we can also calculate its length, which will be equals to 2b square upon a square. So similarly you can work out for the case of hyperbola. Let's just get the basic idea of how to derive it. We'll have focus at again c comma 0, and this will be, say, the latest rectum, and to calculate its length and the coordinates, just put the x coordinate in the equation equals to c, and you will get the answer. You'll get the same answer. So please try out. Thank you. I hope in this video tutorial you might have got some of the concepts of conic.